Hey, now the AP test is coming up, I want to really dial in on how to maximize your chances of getting a 5 on the test. And one of the ways you can do that is making sure that you hit the experimental design FRQ out of the ballpark. And you can. It's a known quantity. You know it's coming, and usually they're asking you to do something that's pretty straightforward, okay? All right, so I just took one at random here. It's one where I'm not going to give you the background, but basically what they've got is you're told in the prompt that you have a toy that's like a spring that jumps up in the air, and we're told how much it got compressed and how high it jumped. Okay, and then the first prompt says derive an expression for the height in terms of for height h in terms of mass x, k, and other fundamental constants, by which they mean in this case g. All right, so I'm looking at this and go, all right. First of all, you cannot go forward until you decide what area of physics is this and what is the equation for it. Clearly, this is about conservation of energy. All right, I have a spring, but it's not about period. It's about how high it jumps. So I go, okay, it's conservation of energy. So hopefully you have done as I asked and have memorized all the equations we've used this year, and you know this. And you know this one here. Okay. Now I look at this equation once I've written it down and say, all right, let's analyze this. Well, it's on the ground to start with, so it doesn't have any UG. The spring is compressed, so it does have US. It is not moving, so it doesn't have any K. So all I have on the before side is US. When it gets to the top, it has gone up in distance, so it does have UG, but the spring is no longer compressed, so there's no US. And at the top, at maximum height, it's not moving, so it's got a value of K. So this equation just becomes US equals UG. Again, if you've memorized what US is and you've memorized what UG is, then you're ready to go. If you haven't, now you're going through all the equations, trying to figure it out, and you're using up precious time on the AP test. Believe me when I say the best thing you could do for your chance of being successful on the AP test is to memorize all the equations. Okay, now that I've got this, I'm just going to rearrange this in such a way that I'm expressing it in terms of h is equal to, so that gives me this, h is equal to kx squared over 2mg. Now that I've got that, I'm ready to move forward to the next prompt. The next prompt says, with a spring compressed a given distance, in this case 0.02 in each trial, the students obtain the following data. And they give me, I see one column here is mass in kilograms, and the other one is height in meters. Now it says, what quantity should be graphed so that the slope of the best fit line of a best fit line through the data points can calculate the spring constant? You're going to have to linearize. Guys, on your AP test, there is a very high probability that they're going to give you a data set like this and then ask you how you would go about linearizing it. It's just what they usually do. I mean, I can't promise you, but I'm saying high certainty that's what they're going to do. So I'm looking at this. So what I need to do is I need to go back at this point. Before I just start randomly guessing, I'm going to go ahead and say, what is the equation I derived? And by the way, they may not have even asked you to derive this equation. Even if they don't, you need to derive the equation, because what you want to build is you want to express it as A is equal to, y is equal to slope times x. That's how you want to express a linear relationship, right? Y equals slope x. So in this case, my y variable is going to be height, okay? And my x variable that I need to plot is going to be, I see they collected mass data, so I can't use m, I have to use 1 over m, because that's where it is in my linearized equation. So my other column has to be the reciprocal of m. Because when I plot it, if I plot height over reciprocal m, it should give me a straight line, because this is my y variable and this is my x variable. So let's go ahead and do that then. So a couple things to be mindful of. All right, first of all, it says including units. It will always say including units. So I look here, and it says you can change both of these, but it's the mass I need to change, right? Because I'm going to plot, this is just my y variable, but 1 over this is my x variable. So I'm going to say 1 over m, and then I'm going to give the units, kg to the negative 1, or 1 over kg, whichever. And now I have to go ahead and take each of these values and take the reciprocal of them, because that's what I'm saying I'm plotting. So I get the reciprocal of each of these. Okay, but my point is, make sure you include the units when they say to. Now, here's the real thing I want to talk about. This is the thing I'm most concerned for you, all right? You know how to do this. You just don't practice it a lot. And the other day, I looked at some of you, and you guys are doing some pretty weird things. So let's just talk about this. On the axes below, plot your data and draw a best fit straight line. Label the axes and indicate the scale. Okay, label the axes. Let's just start with that. Always label your axes. This is height in meters. This is 1 over mass in kilograms to the negative 1. You got to put that down. Now, here's the next thing. use consistent increments that make it at least halfway up the axis. Okay, so for height, I know my maximum height was, I think, 0.49. So I had to say, okay, I'm going to say, well, if this is 1, 2, 3, 4, 5, I have 6. So I decided to go by 0.1s. And when I calculate the reciprocal, my largest reciprocal was 0.49 or 0.5, I forget whichever. So I'm going to go out to here. So don't do like a little zigzag and start somewhere. Don't do that. Don't take all your data and make that here, right? These should not be the values of your data points. These should just be consistent increments that are going to allow you to plot your data. Now I plot my data, and they're probably going to give you data that doesn't exactly plot as a straight line, because you know what? When people collect data, there's errors in it. That's the whole point of a best fit line. A best fit line is a way of smoothing out or averaging out the errors associated with each individual data point. That's the point of it, okay? So you're going to use a ruler to draw a best fit line if it's straight, which it will be in a linearization. If otherwise, obviously, sometimes they ask you to draw a curve, right? But if you're supposed to draw a straight line, do not do it by hand. You must use a straight edge. Now, they'll often ask you to make a calculation. So like they might ask you to make a calculation, say, for a height of 0.2 meters. Now notice here, this point is below the best fit line. They're looking to make sure you use the line rather than the data point. That is absolutely a look for on the scoring guideline. Does the student understand that the best fit line is what's supposed to be trusted, not the individual data points, because each individual data point has some unknown error associated with it. And so you just draw a best fit line in order to smooth out those errors. Now, another thing they're going to ask you on this, and we're almost done here, is to state one way in which the student could improve the accuracy of the results if they were to perform it again. And often they ask you to justify. All right, so there's two different ways you're going to do this. But be ready, because you're going to get asked this question. So the easiest thing to say is, look, repeat these measurements several times and then plot the average value. And the justification is that this reduces the random errors associated with collecting data. Anytime I collect data, there's errors associated with human reflex, parallax, where my eyes are. There's just so many different things that can cause error. But if you take multiple trials and then take an average, that reduces those random errors associated with data collection. All right, that's my suggestion. Use that one. Another one that you could say is collect the data over a greater range, because if you collect it over a greater range, your justification is it gives you a better ability to draw an accurate best fit line. So if your data is kind of crunched in, your best fit line is hard to do. But if you collect it over a greater range, you have a better ability to do that. So that's all there is to do to make a high score on your experimental design section of the AP test. Thank you for paying attention. And let's rock this test, guys.